Department of Mechanical Engineering, ANITS. So today I am going to explain to you about two different things which are in the analytical process of relating to synthesis of four-bar mechanism. So now let us see about synthesis of four-bar mechanism. This is also known as Freudenstein's equation. So we are going to derive the equation for this. This is very important topic in synthesis analytical procedures. So now let us start synthesis of four-bar mechanism for function generation problem. So we know about the function generation problem, what it is. So the functional relationships, we have the internal or input link motion parameters having the functional relationship with the output or external links or output link. That thing or that functional relationship will be called as function generation problem. So now let us solve the problem analytically. Initially in the earlier topics we have discussed about the graphical approaches. So now we are going to study about the function generation problems analytically. So in this analytical approach we have two different methods. First one will be called as a Freudenstein's equation and second one will be related to the Bloch's method of synthesis. So now let us see about the Freudenstein's equation. He has derived for the synthesis of four-bar mechanism for function generation problem. So now let us see the four-bar mechanism. So we have four bars, first one, second link, third link and fourth link. So now let us locate the points A, B, C and D. So now let us locate the magnitudes A, small b, small c and small d. So we are considering this four-bar mechanism. Now let us see about the four links and having the magnitudes. Those are small a, small b, small c, small d. So let us consider those magnitudes as vectors. So for the vector equation we have to write. So for this four-bar mechanism, let us write the vector equation. So we are considering the vectors like this. So initial one, the input link AB, which makes an angle theta with respect to the x-axis, and this is the output link CD, which makes an angle phi with respect to the horizontal line. So here we have one more angle, that is beta. So with respect to the horizontal line, the coupler or the floating link which makes an angle beta. So this is about four-bar mechanism. Now let us do the derivation. So let us write the vector equation. Initially in polar form we will write the equation A e power I theta plus B e power I beta is equal to C e power I phi plus D e power I 0. So I 0. So now this is in polar form. We have written the equation. Now let us write this equation in Cartesian form. So A cos theta plus I sin theta plus B cos beta plus IB sin beta, that is equal to C cos phi plus IC sin phi plus D cos 0 degrees plus I D cos sin 0 degrees. So this is the equation which is written in the Cartesian form. So now let us write the equation again. A cos theta plus I sin theta plus B cos beta plus IB sine theta, that is equal to C cos phi plus IC sine phi plus here d cos 0 degrees, it is d. So this is the first equation, equation number 1. So now let us write the displacement equation. Displacement equation along x direction. So now we need to consider a cos theta, b cos beta, c cos phi and d. A cos theta plus b cos beta is equal to c cos phi plus d. So now let us separate this one to get b cos beta, c cos phi plus d minus, this will come here, a cos theta. So now squaring on both sides, b square cos square beta is equal to c square cos square phi plus d square plus a square cos square theta plus 2c d cos phi minus 2ad cos theta minus 2ac cos phi and cos theta. So this is the equation we have obtained. B square cos square theta, c square cos square phi plus d square plus a square cos square theta plus 2cd cos phi. Next 2 minus 2ad cos theta. Next minus 2ac cos theta cos phi. So that is what we have obtained. So now let us consider this equation as the second equation. So now from this equation, let us write the equation for displacement along y direction. Along y direction. So how to get I multiples? We have to write a sin theta plus b sin theta is equal to c sin phi. So this is the equation, displacement equation along y direction. So now let us find b sin beta, that can be written as c sin phi minus a sin theta. So we have obtained this equation from this equation, a sin theta plus b sin beta, I multiples, is equal to c sin phi, we have obtained. So now from that we have to obtain b sin beta, it is equal to c sin phi minus a sin theta. Now squaring on both sides, b square sin square beta is equal to a minus b whole square formula, c square sin square phi plus a square sin square theta minus 2ac sin phi sin theta. So let us consider this as the third equation. So now from the first two equations, 2 and 3. So let us write the final equation by adding 2 and 3. Let us add these two. So that we'll be getting b cos square beta plus b sin square beta in the LHS left hand side. That is equal to b square. So equal to c square cos square phi, c square sin square phi. By adding, we will get c square. Next one, d square plus a square cos square theta, a square sin square theta. Add these two, then we will get a square of cos square theta plus sin square theta. It is nothing but a square, right? So next thing is plus 2cd cos phi minus 2ad cos theta minus 2ac cos phi cos theta minus 2ac sin phi sin theta. So now let us write this equation by taking common 2ac as common. So consider that particular part here. So then let us write this equation: a square minus b square plus c square plus d square plus 2cd cos phi minus 2ad cos theta minus 2ac of cos phi cos theta plus, we are taking minuses common, sin phi sin theta. So here we are considering 2ac as common, right? So now let us write the equation. So let us pray 2ct cos phi minus 2ad cos theta plus a square minus b square plus c square plus d square. It is equal to 2ac. We can write this as cos theta minus phi or phi minus theta. So now 2cd by 2ac, 2ad by 2ac, we will consider a square minus b square plus c square plus d square divided by 2ac. So then we will get d by a cos phi minus d by c cos theta plus a square minus b square plus c square plus d square whole divided by 2ac. That is one part. That is equal to cos theta minus phi. So this equation will be known as Rudolph's equation. So in order to get the magnitudes of all the links in a 4-bar mechanism, we have to use this particular equation. This equation will be called as Rudolph's equation. So now let us write this equation as k1 or k1 cos phi minus k2 cos theta plus, this will be considered with another constant k3 is equal to cos theta minus phi. So you can here use plus sign also. Therefore k1 it is equal to d by a, k2 it is equal to minus d by c. Okay. Next to k3 it is equal to a square minus b square plus c square plus d square by 2ac. So these are the constants we have to find. So in order to find all these constants, so for input link motion parameters we have to consider, and output motion parameters we have to consider. For this particular motion parameters or this 4-bar mechanism, we have to consider input link angle as theta and output link angles as phi. So for 3 positions, so we may consider for input links or for any input link, we will consider theta 1, theta 2 and theta 3. For output link, so we have to consider phi 1, phi 2, phi 3, right? So now from this relation let us write 3 equations. K1 cos phi 1 plus K2 cos theta 1 plus K3. So we are writing all the equations from here. K3 it is equal to cos theta 1 minus phi 1. So let us consider this as equation A. So similarly you have to write second equation basing on second position plus K2 cos theta 2 plus K3 cos theta 2 minus phi 2. So this is the second equation B. Next, K1 cos phi 3 plus K2 cos theta 3 plus K3 is equal to cos theta 3, sorry this is 2, this is 3, and this is the third equation C. So now for these 3 equations we have to write the matrix forms to get the values of constants K1, K2 and K3, and finally we have to obtain the magnitudes of all the links A, small b, small c and small d. So for that we have to use Cramer's rule from the matrix applications. So now let us write delta it is equal to cos phi 1 cos theta 1 next cos phi 2 cos theta 2 1 cos phi 3 cos theta 3 and 1. So now let us write delta 1 cos theta 1 minus phi 1 cos theta 2 phi 2 cos theta 3 phi 3. Next second line is cos theta 1 cos theta 2 cos theta 3. Next final 1 1 1. So next one is delta 2. So how to write delta 2? Cos phi 1, cos phi 2, cos phi 3, and second line will be RHS cos theta 1 minus phi 1, cos theta 2 minus phi 2, cos theta 3 minus phi 2. And final line is, so next one is delta 3 cos phi 1, cos phi 2, cos phi 3, and second line is cos theta 1, cos theta 2, cos theta 3, and final line is cos theta 1 minus phi 1, cos theta 2 minus phi 2, cos theta 3 minus phi 3. So likewise we have to find the depths. So to get K1, that is equal to delta 1 by delta. So we will get K2 from delta 2 by delta. K3, we will get K3 from delta 3 by delta. So after getting all these constants, we have to find, or we can find A value, B value, C and D. From which relation? So from these relations we will get A value, D value, C values. So K1 it is equal to D by A, K2 is equal to minus D by C. So K1 is equal to D by A, K2 is equal to minus D by C, and K3 is equal to A square minus B square plus C square plus D square by 2A. So you have to obtain all these magnitudes A, D and C. So after getting A, B, C and D, we will finish our synthesis of 4-bar mechanism relating for the function generation problem. So this is derived from the equation will be called as a Freudenstein's equation. So now let us see about the Bloch's method of synthesis. So why we need to consider this invention done by Bloch's. So that is very important. So the main difference between Freudenstein's approach and Bloch's method of synthesis is, so there we have removed the beta value, that is relating the value which is relating to the coupler, or the link it is placed exactly opposite to the fixed link. That link will be called as a floating link or coupler. So that particular value it is removed. So if you want to consider the coupler angle or floating link angle beta, so then we have to use that the particular approach will be called as a Bloch's method of synthesis. So now let us do the procedure basing on the same 4-bar mechanism. So we are considering 4 links. Points are A, B, C, D. And first one is, the magnitude is R1, R2, R3 and R4. So now let us consider, this is theta 1, this is theta 2, this is theta 3 and this one is theta 4. So now let us generate the equations for this particular thing. So initially we have to write the vector equation in the polar form. So r1 into e power I theta 1 plus r2 e power I theta 2 plus r3 e power I theta 3 plus r4 e power I theta 4, it is equal to 0. So this is the first equation. You know about theta, this is the angular displacement, and omega is the angular velocity d theta by dt. And what is about angular acceleration alpha? This is d omega by dt or d square theta by dt square. Because this is the constant, because this equation or this line, this link will not move, so that will be a constant. So that we will be getting r2 omega 2 e power I theta 2 plus r3 omega 3 e power I theta 3 plus r4 omega 4 e power I theta 4, it is equal to 0. Okay, so now again differentiate the second equation with respect to time t, so that we will be getting the acceleration relation r2 alpha 2 plus I omega 2 square into e power I theta 2 plus r3 into alpha 3 plus I omega 3 square into e power I theta 3. So next one is r4 into alpha 4 plus I omega 4 square into e power I theta 4 is equal to 0. This will be the third equation. So now we have obtained three relations. For these three relations we have to write the matrix form. So first one, so in the right hand side we will write the constants. So from the first relation we have r1, that is as constant. So here we have to write -1, and for the second equation we have no constants. For the third equation also we have no constants, 0. So by considering these three relations, so we have multiplication factors of coefficients r2, r3, r4 common. So now write r2, r3 and r4. So now finally let us write the matrix form: 1 r2 into 1, r3 into 1, r4 into 1. Next here r2 into omega 2, r3 into omega 3, r4 into omega 4. Next one, r2 into omega 2 plus I omega 2 square. Next r3 into alpha 3 plus I omega 3 square. Next r4 into alpha 4 plus I omega 4 square. So now for this we will get delta, that is equal to det 1 1 1 omega 2 omega 3 omega 4. Next one is alpha 2 plus I omega 2 square, alpha 3 plus I omega 3 square, alpha 4 plus I omega 4 square. Likewise we have to write delta 1, that is equal to, so from here -1 0 0, -1 0 0, and remaining two lines are same: 1 omega 3 alpha 3 plus I omega 3 square. Next 1 omega 4 alpha 4 plus I omega 4 square. So this is about delta 1. Next delta 2. Likewise we have to get delta 2 and delta 3 values. So finally, after getting delta 2, delta 3, delta 1, delta, so we will get R1 or R2 as delta 1 by delta. Next, R3 as, this is delta 2, delta 3 by delta. Next, R4, delta 4 by delta. Okay, so we will get the equations from here. So after getting this, so we will get the final equations, that is as R2 is equal to omega 4, omega 2 and omega 3 values, and basing on this we have to find final answers. Alpha 3 plus I omega 3 square minus omega 3 into alpha 4 plus I omega 4 square. Alpha 4 plus I omega 4 square minus omega 4 into alpha 2 plus I omega 2 square. The final equation, omega 3 into alpha 2 plus I omega 2 square minus omega 2 into alpha 3 plus I omega 3 square. So these are the relations are very important to get the magnitudes. How to get R1 value? We will get R1 value as minus R2 minus R3 minus R4. So likewise we have to find the magnitudes of the 4-bar mechanism when you want to consider the coupler angle, that is beta in case of Rudinstein's equation. Here that is theta 3 we are considering. So this is what about the main difference between the Rudinstein's equation and Bloch's method of synthesis. Thank you for watching. Thank you.